Welcome to the Rational Functions family. They live in Unit 4 of the City Nelson's Advanced Functions textbook. This is Mother Mary reciprocal. She is the parent function 1 over something. Through Mary's mother's genetic 0, she inherited an asymptote at the x value of her mother's 0. Also, like her mother Mary, is very positive and lively above the x-axis, and is negative and moody below the x-axis. As time progresses, Mary's mother gets larger. Mary wants to be smaller. Let's see what Mary's children look like. They get their traits from their different fathers. If Rachel's father was linear, Rachel would have one asymptote at her father's 0. You can also see that Rachel is positive where her father is positive, and negative where her father is negative. If Ryan's father was a quadratic with 2 zeros, Ryan would have 2 corresponding asymptotes to his father's zeros. This causes him to have 3 separate parts. The positive parts of Ryan's father still correspond to the positive parts of Ryan. For the negative part of Ryan's father, Ryan is still negative, and when Ryan's father is big, Ryan is still small. This produces a parabola-like shape that opens down as shown. If Rob's father was a quadratic with 1 0, Rob would have 1 asymptote. Rob would look different than his sister Rachel, who had 1 asymptote because Rob is always positive. Therefore, this is what Rob would look like. If Rose's father was a quadratic with no zeros, Rose would have no asymptotes and look like this. We could describe Mother Mary's family's features by using the following properties, which can be found using the equation. To find their vertical asymptotes, we set cx plus d equal to 0 and solve for x. This would be the x value that makes the denominator 0. To determine whether they have a horizontal asymptote, we check if the degree of the numerator is less than or equal to the degree of the denominator. To figure out the y value of the horizontal asymptote, you solve for a over c. To see if Mary's children have any holes, we have to determine if there is a factor in the equation. In the example, we first need to factor out a 2 in the denominator. Once we do this, it is apparent that x plus 2 is a factor. So, the whole would be at negative 2, because it is the x value that makes the factor equal to 0. To figure out the zeros of Mary's children, we just solve for when the numerator equals 0. This is the same as solving for ax plus b. In the example, we can eliminate the denominator by multiplying it on both sides. Then we solve 0 equals 3x plus 1 and get a final answer of x equals 1 over 3. By doing a DNA test, we can figure out if any of them have an oblique asymptote by seeing if the degree of the numerator is 1 greater than the degree of the denominator. If this is not the case, there is no oblique asymptote. Mary's children have many rules brought upon their fathers. These rules correspond to the restrictions in the domain and range. Rachel's rules are such that x is an element of real numbers such that x cannot equal negative 3. Her range is y is an element of real numbers such that y cannot equal 0. In Ryan's house, his rules are x is an element of the real numbers such that x cannot equal negative 2 and x cannot equal 2. His range is y is an element of real numbers such that y cannot equal 0. In Rob's house, his rules are x is an element of real numbers such that x cannot equal 1. His range is y is an element of real numbers such that y is greater than 0. In Rose's house, their rules are x is an element of any real number. Her range is y is an element of any real number such that 0.5 is less than y, which is less than positive 1. Shown now, it's a quick summary of how to calculate many of these properties. Let's see how these rules work out. We start by factoring the denominator, and now we have x plus 5 over x minus 2 times x plus 5. It should be clear that x plus 5 is a whole. So now our equation is 1 over x minus 2. From this, we know that the horizontal asymptote is y equals 0, and the vertical asymptote is at x equals 2. We can see these properties on the graph. We can show Mary's children where they share points by using rational equations. First, let's go over the steps to solve a rational equation. First, we state the restrictions. Second, we get a common denominator. Third, simplify numerator and solve. 4, state final answer and restrictions. For example, we start with the equation x minus 3 over x plus 3 equals 2. First, we need to state the restrictions and the value of the common denominator. The next step is to bring everything to one side so it equals to 0. After that, we need to have a common denominator since we are subtracting. To achieve this, we just multiply 2 over 1 by x plus 3 over x plus 3. Now we can factor in the 2 and carry out the subtraction in the numerator. Then we just need to solve for x. To do that, we can begin by eliminating the denominator by multiplying it by 0. Now we just have negative x, negative 9 equals 0, and we simply solve for x. Therefore, x equals negative 9. If we had a quadratic here, instead we would have just found the solutions of the quadratic. We also have the knowledge to show Mary's children where one of them is bigger or smaller than the other. To show this, we use rational inequalities. The steps to solve a rational inequality are: set one side equal to 0, state common denominator and restrictions, get common denominator, factor numerator, state zeros and vertical asymptotes, use zeros and vertical asymptotes in factor table, state final answer. For example, if we begin with 3 over x minus 2 is less than 4 over x, our first step is to bring everything to one side, so the other side is equal to 0. Next, we have to state our restrictions, which come from the denominator equaling 0, or in other words, the vertical asymptotes, and the common denominator. Now we need to establish our common denominator. After that, we factor in the numerator and they carry out our subtraction. Now the inequality is in its simplest form of negative x plus 8 over x multiplied by x minus 2. Our next step is to state the x values of the vertical asymptotes, which are x equal 2 and x equals 0, and the zeros of which we only have one, where x equals 8. These come from the values that make the numerator or denominator equal 0. After we have these values and we put them in our interval table, in the interval x is greater than 0, the sign is positive. When x is between 0 and 2, the sign is negative. For x is between 2 and 8, the sign is positive, and in the interval is x is greater than 8, so the sign is negative. Therefore, the inequality is satisfied for 0 is less than x, which is less than 2, and x is greater than 8. Mary's family doctor has the knowledge to calculate the growth of the children over the years. He can do this using the AROC equation, f at x2 minus f at x1 over x2 minus x1. The doctor only has limitations at any x value of discontinuity. This is because the function doesn't exist at these points, so you can't cross a whole or a vertical asymptote when calculating AROC. Let's look at an example. We start out with our basic equation and sub in the x values. We are going to find AROC between x equals 2 and x equals 7. For the equation x plus 2 over x minus 1, we have f at 7 minus f at 2 over 7 minus 2. Now we have to find f at 7 and f at 2. To do this, we just sub in the x values and solve. Therefore, f at 7 equals 1.5 and f at 2 equals 4. So back with our other equation, we have 1.5 minus 4 over 7 minus 2, which equals negative 2.5 over 5. Our final answer is an average rate of change of negative 0.5. This negative value corresponds to a decreasing portion of the graph. Dr. Function, who assesses the properties of all functions, can also calculate Mary's family's IROC at any x value. As with AROC, IROC cannot be calculated at an x value of discontinuity, which is either a whole or a vertical. Let's try an example using the IROC equation, f at x plus h minus f at x over h. Using the equation x over x minus 4, we will calculate IROC at 2. To do this, we need to calculate IROC at x equals 2.001 and x equals 2. So f at 2.001 is negative 1.001005, and f at 2 is negative 1. In our equation now we have negative 1.001005 subtract negative 1 over decimal 001. When we calculate that, we find that negative 1.0005 is the instantaneous. Now we know everything there is to know about Mary's family, who lives in the Unit 4 of the Nelson's Advanced Functions textbook.